What's up, guys? How are you doing today? Today, I want to do an energy problem that involves a roller coaster, which some people are having a little bit of trouble with, and that's okay. It is not physically very difficult, but mathematically, it is slightly annoying. So what I'm going to give you right now are all of the givens in this problem, and essentially it says there is a roller coaster up here which starts with an initial velocity of 0 meters per second. Okay? And it tells you that it starts at a height of 2h. At the lowest point here, where position is 0, it has a speed equal to v. And they want to know what is the speed here, but it has to be in terms of v. And when I say in terms of v, I mean this v. So our final answer has to be in terms of v. It can't have any of those other variables in there, no h's, and that's kind of like where this gets a little bit confusing mathematically. So first I'm going to say that right here we are going to have some gravitational potential energy. It has no kinetic energy because this speed is equal to 0. Down here, all of that potential energy is going to be equal to the kinetic energy of that cart right there. Then it's going to start to go up some h, but right here it's still going to have some speed. So down here it's going to have ke plus the ug over here. All right, now essentially what I'm going to do is I'm going to set this up into two problems. First, I'm going to come with this relationship right here. I'm going to work with just that relationship. And I'm going to say that mg 2h, right? Because in this case, delta y is 2h, is equal to 1/2 mv squared. All right? That is all of this being converted to kinetic energy. And when we set that up, we can see that these m's are going to cancel out. And I'm going to bring this 2 out in front just to make the math a little bit easier and clean that up. So we can say that 2gh is equal to 1/2 v squared. Okay? So now when I manipulate this, I'm going to make an expression for h so that I can cancel it out in this part. Because like I said, it has to be in terms of v. So when I do some math, I see that h is going to be equal to v squared over 4g. All right, and what I'm going to do is I'm going to save this expression for the second part. So now what I'm going to do is I'm going to look at this relationship here, and I'm going to try and come up with my final answer. So if I set this up again, 1/2. Now, so I don't get my m's confused, my v's confused, I'm going to do mv initial squared. That's what this thing has to be in terms of. So that's the only variable we're allowed to have left. That's going to be equal to 1/2 mv final squared. This is what they want us to find. How fast is it going? Plus mg delta y, right? But the delta y in this case is h. So I'm going to plug in h right here. And once again, I can cancel out all of the m's to make my life a little bit easier. To get rid of the halves, I'm going to multiply everything by 2 because I hate 1/2. So I'm going to get v initial squared equals v final squared plus 2gh. All right, now this is pretty simplified, but like I said, I can only have it in terms of this. So I'm going to rewrite this and say that VF, because that's what I'm going to want to know at the end, that is going to be equal to VI squared minus 2G. And what I'm going to do is I'm going to substitute this H in over here. And that H becomes V initial squared over 4G. Okay, now I am almost there. I can now cancel these g's out and simplify this into v initial squared minus 1/2 V initial squared. All right? And a whole minus a half equals a half, correct? So V final squared equals 1/2 V initial squared. All right? Now, if I want to simplify this even further, because I need this to be V, I'm going to square root both sides. So let's square root both sides of this whole thing. And what my final answer comes to is VF in terms of just VI is equal to VI divided by rad 2. All right, guys? So if you have a multiple choice, they probably won't put the VF equals. They'll just have VI over rad 2. Hope that helps you with this problem, guys.